question asks, how many sigma bonds are in the following molecule and what are the geometries of the nitrogen atoms? So to answer this question, we have to know what is a sigma bond. And we have to have knowledge of geometry and kind of what determines geometry, such as hybridization. So sigma bonds are pretty much going to be made up of any single bond in your molecule. And then sigma bonds are also present in pi bonds. So we can kind of take that into account. And then geometries are going to depend on, is our atom sp3 hybridized, sp2 hybridized, sp hybridized, etc. So we'll take a look at this specific molecule and then think it out. So first off, I'm going to count up the number of sigma bonds. And the easiest way to do that is just to kind of write them down and keep track. Okay, so every single bond is a sigma bond. And then every double bond also has one sigma bond in it. So I'm just going to work my way around this molecule, adding up all of the sigma bonds. Make sure that you don't forget the carbon to hydrogen bonds because those also count. There's 27 right there. All right, so 27 sigma bonds. If we look at our answer choices, we can cross a couple off. We can cross off B, we can cross off E and D. The reason why I'm crossing those off is because they say there's only 24 sigma bonds, and that might have been if you had forgotten that double bonds also have sigma bonds. So next, let's take a look at the geometry of our nitrogen atoms. So nitrogen number 1 is right here. This nitrogen atom has a steric number of 3, because if we think about it, it has one single bond here, one double bond here, and then a lone pair that has that exists in a hybridized orbital. Right, so steric number of 3, and typically molecules with a steric number of 3 are going to be sp2 hybridized. Oops, sorry, let me write that clearer. sp2 hybridized. sp2 hybridized atoms are typically going to have trigonal planar geometry. That's because they're going to have all their electrons that are present as far apart as possible. Next, let's take a look at the second nitrogen atom. This nitrogen atom, if you were to kind of draw it out, it's going to have a steric number of 4, 1, 2, 3, and 4. So it's going to probably be sp3 hybridized. In this instance, that lone pair is not adjacent to any pi bonds, and so we don't have to worry about kind of that lone pair kind of participating in resonance, which is a topic that we discuss later on. So that lone pair is kind of an isolated lone pair, and so it's going to definitely be in a hybridized orbital. So that is an sp3 hybridized nitrogen. And typically those have tetrahedral geometries. So if we look at our answer choices, answer choice A has trigonal planar for N1 and tetrahedral for 2. So that looks good. Let's just double check C. C says tetrahedral for both. So that's incorrect. So the correct answer for this question is A.